In this video, I'm going to show you how to solve exponential equations using logarithms. So first of all, we want to solve this equation 5 to the power of 3x equals 1 over 25. Now, this would be a lot easier if the right-hand side were a power of 5, because then we would just know that the exponents have to be equal. But hey, 25 is a power of 5. It's just 5 squared. So let's write this as 5 to the 3x is equal to 1 over 5 squared. Yes, the right-hand side is still a fraction, but that's okay because 1 over 5 squared is just 5 to the power of negative 2. In order to get an expression out of the denominator, all we have to do is flip the sign of the exponent. So 1 over 5 squared is really equal to 5 to the power of negative 2. So now we have both sides as a power of 5. And we know that the exponents have to be equal. 3x has to equal negative 2. So we can just divide both sides by 3 and get x equals negative 2/3. And we're done. We've got it. There's our solution. Alright, next up we want to solve this equation. 3 to the power of x plus 2 equals 15. And we'll be rounding our answer to 3 decimal places because it won't come out to a nice clean number. The thing that makes this equation a little bit tricky is that the right-hand side, 15, is not an integer power of 3. So how do we even approach this problem? Well, let's start by writing it down once more. 3 to the power of x plus 2 equals 15. If this were just 3 times x plus 2, we could just divide by 3. It's not, but that offers a little bit of insight. This x is kind of wrapped up in this exponent here in the 3. So to get it, we want to somehow undo this exponent. And in order to do that, all we have to do is apply the inverse of exponentiation, and that's just the logarithm base 3. So we can apply log base 3 to both sides here. And that log base 3 will cancel out the 3 that forms the base of this exponentiated expression. So all we have left on the left-hand side is x plus 2. And on the right-hand side, we've got log base 3 of 15. To solve for x, all we have to do is subtract off this 2 now. So x is just equal to log base 3 of 15 minus 2. Now, this here is an exact form of the answer, but we're asked for a decimal form of the answer. We want to round our answer to 3 decimal places. And in order to do that, we have to compute our answer using the calculator. Do you remember how to type in log base 3 of 15 on a calculator? Well, if your calculator is like mine, it doesn't have a log base 3 button. All it has is a log button, which really means log base 10, and a natural log button, or log base e. So what we do is we use the handy change of base formula. That lets us express any logarithm in terms of any base. Let's just choose log base 10 because that's the log button on our calculator here. So log 3 of 15 expressed in terms of log base 10 is just log base 10 of the argument, 15, divided by log base 10 of the original base, which was 3. So that amount minus 2. So let's go ahead and type that in on the calculator. X is log base 10 of 15 divided by log base 10 of 3. So we'll compute that and then subtract 2. So our answer then minus 2. So there we see that x is approximately equal to, rounded to 3 decimal places, 0.4649, which rounds to 5. So there we go. There's our solution. X is approximately equal to 0.465. Here's our next question. We want to solve the equation 2 to the power of 3x minus 5 equals the square root of 7. And we want to round our answer to 3 decimal places. So let's go ahead and write down this equation again. 2 to the power of 3x minus 5 is equal to the square root of 7. Again, our x is wrapped up in an exponent that has base 2. So how do we undo this exponent? Well, we just used logarithm. Logarithm base 2. So logarithm base 2 applied to both sides helps our equation simplify a lot. It cancels out this base 2 in the exponent, and all we have left on the left-hand side is the original exponent, 3x minus 5. So that's equal to log 2 of square root of 7. But why don't we simplify this a little bit? Remember that one of the properties of logarithms is that we can move an exponent outside of the logarithm. So let's write this root 7 as the power 7 to the 1/2. It's an equivalent form of root 7, just written with an exponent. And that means we can simplify this expression by moving this exponent out in front of the logarithm. So equals 1/2 logarithm base 2 of 7. And the left-hand side stays the same, 3x minus 5. Now to solve for x, we can start by canceling out that minus 5. So just add 5 to both sides to get 3x equals 1/2 log base 2 of 7 plus 5. And then we'll just go ahead and divide by 3 to get x equals 1/2 logarithm base 2 of 7 plus 5, then all over 3. Again, this is the exact form of our answer, but we want the decimal form rounded to 3 decimal places, so we're going to have to go ahead and compute this. We'll use the change of base formula again, expressing this logarithm base 2 of 7 as logarithm base 10 of 7 divided by logarithm base 10 of 2. That way we can actually use our calculator. So let's go ahead and type this in on the calculator. First we'll start by computing this fraction, log base 10 of 7 over log base 10 of 2. Go ahead and type that in, log base 10 of 7 divided by log base 10 of 2. That result is here. Now let's go ahead and multiply that by 1/2. And then add 5, and that'll be our numerator, but we still have to divide by the denominator, which is 3. So we see that x is approximately, rounded to 3 decimal places, 2.1345, which rounds to 5. So there we go. We've got our answer rounded to 3 decimal places. X is approximately 2.135. Now we know how to solve exponential equations using logarithms. In the future, we'll continue learning how to solve exponential equations, including exponential equations which have different bases.